Hello everyone, and welcome to another video brought to you by RouTube. In this video, I will be covering some basic trigonometry as well as some CAS calculator skills. Students will begin to study trigonometry in Year 9, but this content may be useful for Year 10 students also. Okay, so there's three learning objectives from the video. The first one is to identify the hypotenuse. Now, hopefully you're familiar with the hypotenuse and what that relates to if you've previously studied Pythagoras. Pythagoras' theorem. If you're not too sure, probably best to watch my Pythagoras theorem video to sort of get your head around the hypotenuse. So the first objective is to identify the hypotenuse, the opposite and adjacent sides of a right-angled triangle with respect to a reference angle. The second objective is to use trigonometric ratios to calculate an unknown side length of a right-angled triangle with and without the use of a CAS calculator. Okay, so I do understand that some students in Year 9, depending on the secondary school that you're at, will have a CAS calculator in Year 9, whereas some students might get introduced to the CAS calculator at Year 10. So I'm going to cover the scientific calculator and also the CAS calculator and the manual way of doing a few things today as well. And the third objective is to use those trigonometric ratios to calculate the unknown angle in a right-angled triangle. So there's a little bit of stuff that we need to cover. Okay, so having a look at trigonometry, I thought the best way to start would be just by having a look at some key terms and some key properties. Now, if you haven't already watched my video on Pythagoras' theorem, I do recommend that you do watch that prior to watching this video, as there are some key properties, including the hypotenuse, that got covered in that video. So, like I said, probably a good idea to watch that video if you haven't already or you don't have a basic understanding about trigonometry. Okay, so trigonometry, what is it? Okay, so trigonometry deals with the relationship between the sides and the angles of a right-angled triangle. When using trigonometry, the three sides of a right-angled triangle must be labelled as the hypotenuse. Okay, so like I said before, if you had watched my Pythagoras theorem video, you should be familiar with the term of the hypotenuse. And the hypotenuse is the longest side of a right-angled triangle, which is always situated opposite the right angle. Okay, and the right angle is that 90-degree box in the bottom left-hand corner of that triangle that you can see on the bottom of the screen. Next, we need to label the opposite side. So the opposite side of a right-angled triangle is the side that is opposite the reference angle. Okay, and the reference angle is often labeled as using theta, which we can see that symbol there in the bottom right-hand corner of that right-angled triangle. So the opposite is opposite the reference angle. The opposite side does not touch the reference angle, which we can see clearly. Okay, and the third side that we need to label is the adjacent side. Okay, so adjacent just meaning next to. Okay, so adjacent side of a right angle triangle is the side that is next to the reference angle. Okay, so we've got the hypotenuse, which is opposite the right angle, the opposite side, which is opposite the reference angle, and the adjacent side, which is adjacent or next to the reference angle. So that makes up our three sides of our right angled triangle when we are labeling using trigonometry. Okay, so now we're going to be introduced to the trigonometric ratios. Okay, so trigonometric ratios can be used to calculate the unknown lengths or the unknown angles in a right angled triangle. Okay, so we can do a couple of different things with them. A specific trigonometric ratio must be selected rather than selecting a ratio at random. The information given in a specific question will dictate with which trigonometric ratio to use. Okay, so like I said, depending on what information you're given in the question, that will sort of point you towards using which ratio. Now, there'll be the odd occasion where you can use a couple of different ratios, but in most questions that you'll encounter, there will be a specific ratio that you have to use in order to solve the problem or solve the question. The three trigonometric ratios are sine theta equals opposite over hypotenuse, which can be abbreviated to. Now we see this here, and we can see if we read it, it looks like sin. Okay, but it's actually sine. So sine theta equals O over H. Okay, so that's the first trigonometric ratio. Next one we have is cosine. So cosine theta equals adjacent over hypotenuse, which can be abbreviated to cos. Cos theta equals A over H, instead of writing adjacent and hypotenuse. And the third and final one is tangent. So tangent theta equals opposite over adjacent, which can be abbreviated to tan theta equals O over A. Okay, and we have this little song that hopefully you've heard before, Sokotoa. Okay, this is just a really good way to remember which two sides go with which ratio. Okay, so for example, SOH means that with sine goes the opposite and the hypotenuse sides. Then CA says that with cos or cosine, A and H, the adjacent and hypotenuse, and then with tangent or tan, that means that the opposite and the adjacent sides are needed to use tan. It's just a good way to remember it, I think. So let's have a look at the question down the bottom. So for the triangle given below, write the equations for the sine, cosine, and tangent ratios of the given angle theta. Now, what I want you to do, pause the video, have a go on your own. My little hint is make sure you label the triangle first and then use the information on the top of the page to help you with writing the equations for the sine, cosine, and tangent ratios. Okay, so hopefully you pause the video and you had a go at your own, and we've got the three answers here. I'll just highlight the three answers here in yellow. So the first one, sine theta equals 5 over 13. Okay, and the way we did that, like I said to you before, make sure you label first, which you can see I've labeled as OAH. So the 5 is opposite the reference angle, which is theta, so that's why it's the opposite. The 13 is opposite the right angle, which is why it's the hypotenuse. And the 12 is next to or adjacent to the reference angle, so therefore that is A. Okay, so we're using sine theta equals O over A, and then just substituting our values of O and H into that ratio. The second one, using cos, we have this one here. So same again, we don't need to label again, we've already labeled, but this time we're just using A and H instead of O and H. And then the third one, tan, again, no need to label again, but we're now using O and A instead of O and H and A and H. Okay, so it's really important, it all starts with labeling. Once you label, things become a lot easier. Okay, so label first, and then you can work out your ratios depending on the information given in the question. Now in this example, we were given all three sides. Now you probably won't be given too many questions like that, but just because we're starting off with trigonometry, we're given a lot more information than we would normally. Okay, just to get you familiar with using the ratios and substituting the values into those ratios. Okay, now let's have a look at using trigonometry to calculate unknown side lengths. So at the start of this video, I said you can use trigonometry to calculate unknown side lengths and unknown angles. So let's have a look at doing the first of those. So unknown side lengths. So when calculating unknown side lengths using trigonometry, there will always be a reference angle and a known side length provided. Okay, so if we have a look at the question down the bottom there, you can see there's a clear reference angle shown or provided and one side length provided and an unknown. Now, what I've done is I have listed 6 steps that you should follow every time you encounter a question like this. Okay, so make sure you follow step by step in that specific order, and then you should hopefully have some success with trigonometry when calculating an unknown side length. Okay, now I'm going to do first I'm going to do it manually with the scientific calculator way, and then after this I will do the way on the CAS calculator. So if you've got a CAS calculator in year 9 or year 10, obviously you can use it, but if you've only got a scientific calculator in year 9, obviously then you'll have to follow the scientific calculator method, which we're going to do now. Okay, so I won't go through each of those steps, we'll go through it as we answer the question. Okay, so let's go straight to the question down the bottom. So use the appropriate trigonometric ratio to calculate the length of the unknown side in the triangle below. Give your answer correct to 2 decimal places. Okay, so we need to round to 2 decimal places. Now, let's have a look at the steps. Okay, so below are the steps to follow when calculating unknown side lengths using trigonometry. First step is label all 3 sides with respect to the reference angle. Okay, so we know what the reference angle is. Sometimes we're going to see it as theta, which is an unknown angle, or sometimes we will be provided with the angle which we have been on this occasion, which is 42 degrees. So opposite the reference angle is going to be O. Opposite the right angle, which is 11, is going to be H, and therefore the side that is next to, adjacent to the reference angle, is the adjacent side. Okay, so that's the first step. We can tick that one off. Second step is to decide which trigonometric ratio to use based on the information given in the question. Okay, so the reference angle is there. Now side A gives us no information whatsoever. It's got no measurement or no unknown. So I cannot use a ratio with A in it. So I have to use the ratio that's got O and H. And if we remember SOHCAHTOA, well, that should mean that we are going to use sine. Okay, so we've now decided that we are going to use sine. Step 3 is to write the chosen trigonometric ratio. So let's do that. So let's write the formula. Let's not worry about substituting anything in yet. So we've got sine theta equals, and then O over H. Okay, so we can give that one a tick as well. Step 4, substitute the values from the question, including the reference angle. Okay, so now we have, instead of writing sine theta, we've now got the angle, which is 42 degrees. Okay, so sine 42 is equal to x, which was O, x over 11. Okay, now you'll notice that the variable is on the top of the fraction. Okay, so when the variable is on the top of the fraction, it's actually a little bit simpler to work out. Okay, so let's have a look. Let's tick off number 4. So we've substituted now. Okay, now, like I said before, if you've got your CAS calculator, you're going to use the nsolve function. But for this example here, I'm going to assume that you're working from a scientific calculator. Okay, so hopefully you know where the trig functions are on the scientific calculator and where the sine button is. Okay, so enter sine 42 equals x over 11 comma x if you're using nsolve, okay, on the CAS calculator. But if you're using a scientific calculator, there's another step that we need to do. Okay, so we need to solve manually. Okay, so we need to isolate x or get x on its own. So what we're going to do is we're going to multiply both sides by 11, both sides of the equation by 11, which is then going to cancel out the 11s on the right hand side, which is then going to leave x on its own, okay, which is what we wanted. Okay, so here we have x equals 11 multiplied by sine 42 degrees. Okay, and then now we can simply just type that into our calculator, into our scientific calculator, and that should hopefully give us an answer. So we have got x equals 7.360, and then rounded to 2 decimal places should be x equals 7.36. Oh, we've got 3604 is there, and then we've got a few more digits after that as well. Okay, so 7.36 should be our measurement. Now it's really important to check your answer. Our answer should be less than 11 because it cannot be larger than the hypotenuse. Okay, so that's another good way to double check. Okay, so this is a manual way to solve or calculate the unknown side length using trigonometry. So we'll tick off step 5 we did, and step 6 we rounded correctly to 2 decimal places. So x equals 7.36. Now, if there were units of measurement, whether they're millimeters, centimeters, or meters, or anything like that, you would obviously need to include them, but there were none in the question, so therefore you do not need to include any in your answer. All right, let's have a look at another question where we need to use trig to calculate unknown side length. Now, like I said before, this question will be fairly similar to the process that we just followed, but it'll be slightly different in sort of step 5 when we get to solving. Okay, but let's have a look. So when the pronumeral is on the bottom of the fraction, another step must be taken in order to solve for the unknown. Okay, this will be evident in the example below. Okay, so we'll get to that in a second. So we're going to use the same 6 steps that we used in the previous example, but this time step 5 we're going to have to do something a little bit different, okay, which we'll get to in a second. So let's have a look at this question. Use the appropriate trigonometric ratio to calculate the length of the unknown side in the triangle below. Okay, give your answer correct 2 decimal places. So the same question as the previous one with a different angle, and we may need to use a different ratio. So let's follow the same steps we did previously. So first step is to label all 3 sides with respect to the reference angle. Okay, so the reference angle is in the bottom left hand corner, which then makes the 6 opposite the right angle, makes a hypotenuse, and then x is the adjacent. So we go back to our trig ratios and we say, well, I've got O and A, the 2 sides that have information are O and A. So hopefully you can identify that we are going to use tan. Okay, so we've ticked off number 2, step 2, which is to decide which ratio we're using. Step 3 is to write the chosen trigonometric ratio. So we're going to use tan theta is equal to O over A. Okay, so TOA. Okay, so step 3 is finished. Then we proceed to step 4, which is to substitute the values from the question, including the reference angle. Okay, so here, now we've got tan, and we're not going to use theta anymore because we know the angle, it's 38 degrees, is equal to, now O is 6 over X, which is the adjacent side. Okay, now, hopefully you'll notice a difference between this question and the previous question. Okay, it looks quite similar. Yes, it's got some different numbers, but the idea is that the pronumeral is on the denominator and not the numerator. Okay, so like I said before, we're going to have to do something a little bit different here. Okay, so what we're going to need to do is we need to do the same thing in the sense that we still need to solve, which means to find the unknown, to find the value of the variable, the pronumeral x. Okay, so what we need to do is we need to multiply both sides by x. Okay, we need to multiply both sides of the equation by x. Okay, and what that'll do to the 2 x's on the right hand side, it'll actually cancel them out. Okay, so what we will have on the left hand side is x multiplied by tan 38 equals 6. Okay, so we've cancelled out the x and brought it to the left hand side. Now the only thing that's attached to the x at the moment is tan 38, and it's being multiplied. So to move it onto the other side, we use the inverse, which is, I'm just going to rewrite this. So we've got x tan 38 equals 6. Now what we need to do is we need to use the inverse of multiplication, which is division. And we're going to divide both sides by tan 38, which is going to move the tan 38 to the right hand side, which is going to isolate our x, which is the objective of the question. So now on the left hand side, we're just left with, these 2 can cancel out, we're just left with x. And then on the right hand side, we're left with 6 over, or divided by, tan 38. Okay, now this is a manual way to do it. Remember, if you've got your CAS, you can just use nsolve, which we'll get to in a second. Okay, so you've got your calculator, your scientific calculator. We can just do 6 divided by tan 38, and that should give us an answer that is 7.6794 and so on. And we need to round to 2 decimal places, which is step number 6. Okay, so 2 decimal places should be 7.6, and then the 7, the digit after the 7 is 5 or above, so that makes the 7-digit increase to 8. So the correct answer of the adjacent side is 7.68. Once again, no unit of measurement. If there is, please make sure you include it in your final answer. All right, so now I'm going to show you how to use the CAS calculator to solve that question that we previously did. Okay, so without doing the transposing where we're moving stuff left and right and using the inverse, if you've got your CAS, you don't need to do any of that. Okay, you can just use, hopefully you've been introduced to the nsolve function on your CAS calculator. If you haven't, I'm going to show you where it is anyway. So like I said, you won't need to do any of that manual stuff because luckily enough, this calculator does it for you. Okay, now the first thing and most important thing is please make sure that in the top right hand corner you are in degree mode. Okay, now if you've got one of the new blue CAS calculators, just check your calculator settings before you start. So if you just press on and then settings and then document settings, okay, hopefully you should be in degree. Now if you're in radian, you probably won't be in radian, but if you're in radian, please make sure that you change to degree, and then either make default if you're on an older black, one of the black CAS calculators, or if you're on a blue, it'll just say okay. Okay, so let's get back into it. Okay, so now we're going to be using tan. Okay, so we're going to use the nsolve function. So it's menu and then algebra number 3 and then option number 6, which is numerical solve. Okay, which will open up a bracket for you. Now it's as simple as we're just going to go to where we substituted the values. Okay, so we're just going to go to step 4, and then we won't need to solve manually. The CAS will do it for you or for us. Okay, so you can type in tan 2 ways. You can either type in TAN using the keyboard down the bottom, or you can hit the trig button and then press on tan. Okay, and then it will open up a bracket for you. Now inside that middle bracket, you're going to type in 38 degrees, or sorry, 38. If you're in degree mode, you don't need to use a degree symbol, okay, because your calculator will recognize that. And then close your bracket, okay, and then you just type it in as you see it. So equals, which is under control, and then you're going to put in your fraction, which is control and then division. And then on the top, you've got 6, and then on the bottom, you've got X. Now, a lot of students stop there and they hit enter and an error message comes up. It's because you haven't told your calculator what you wanted to solve for. Okay, so remember, comma X tells your calculator that you want to find the value of X. Okay, so comma X is almost the command. Okay, so as soon as you do that, you hit enter and you see we skipped the next 2 steps in our previous question. Okay, so the calculator does it all for you. And then if you need to round that answer and you're sort of find rounding a little bit difficult, okay, what you can do, just type in round and open up a bracket. And then from there, you don't need to type in the whole value. You can just press up and then enter, and it will paste the number for you. And we want to round it to 2 decimal places as the question says. So again, your command is comma and then 2, because you want to round it to 2 decimal places. If you want to round it to 1 decimal place, you would put 1, okay, or 3 and so on. So 2 decimal places, we hit enter, and then it's rounded for you. Okay, if you want to round manually, go for it. If you want to solve using the manual method, again, go for it. But if you've got a CAS calculator, as you've seen, it makes things a lot easier and a lot quicker. All right, now moving on to the last thing for this video. So now we're going to use trig to calculate the reference angle. Okay, so like I said at the start of the video, we can calculate missing side lengths or the angle. Okay, so now we're actually going to calculate the reference angle. Okay, so once again, there's a fair few steps here. I'm not going to go through them at the start, but as we're going through the question, we'll go through. So when calculating the reference angle, there will always be 2 side lengths provided, which we can hopefully see on the bottom of the page now. So once again, I've put some steps there. Now you'll see on the right hand side, you'll see inverse trigonometric ratios. Okay, so whenever we are calculating the reference angle, we need to use the inverse trig ratios. Okay, not just the regular ones when we're using sine, cos, or tan with theta to find the value of the side lengths. We use the inverse trig ratios. Okay, so sine -1, cos -1, and tan -1, and hopefully you've seen those buttons on either your CAS calculator or your scientific calculator before, and we're going to use those in a couple of seconds. So let's go down to the bottom where the question is. So determine the value of theta in the triangle shown below. Give your answer correct to the nearest degree. So nearest degree just meaning the whole number. And often when you're asked to calculate an angle, it's generally to the nearest degree. Okay, generally. But as always, read the question and round accordingly. Okay, so we're going to follow the steps. So step 1 is the same as we've seen before. So step 1 is to label all sides with respect to the reference angle. Okay, so by the end of this video, we should hopefully be fairly confident with labeling in terms of trig. So the 5 should be the opposite because it's opposite the reference angle. the 8 should be h because it's opposite the right angle, which leaves as our adjacent as our side with no value. So that means we've got O and H. So once again, we should be using sine. Okay, so we've answered step 1 and we've answered step 2 and we've decided we're using sine. So now we're going to use the inverse. Okay, so I'll just change color. So we now should be using sine -1 x. Okay, so now we can tick that one off, grab my red pen and we can tick that one off. Okay, so now what we do is now we're going to substitute the values from the question. Okay, so now again, we're going to leave the -1 as it is, but inside the brackets, we're actually going to create a fraction because it's just going to be O over H. Okay, so what we're going to do is we're just going to put it as 5 over 8. Okay, so what it's saying is the opposite side is 5, which we know, and the hypotenuse is 8, so therefore calculate the angle for me. That's what you're telling your calculator. Okay, so now if you have a scientific calculator, hopefully you will have seen, you'll probably have sine, cos or tan buttons, and then above that, maybe written in black or a different color, you'll need to activate your second function on the calculator. Okay, so it's really important that you use the inverse and not regular sine, cos or tan when you're finding the angle. You're going to use the inverse. So it should be sine -1, and then in the bracket, you can open up a fraction, and then you just have 5 over 8. So you're typing it in just as you can see it written, and then we should get an answer. So theta is equal to 38.68 and so on, and rounded to the nearest whole number should be, well, the only thing we're interested in is that digit there, that's 6. It's 5 or above, so therefore it becomes 39 with a degree symbol. So 39 degrees. All right, so the CAS calculator is no different to the scientific calculator for a question like this when you're finding the angle, but I thought we'll go through it anyway. Okay, so I'm going to do the previous question just on the CAS. Okay, so we're going to be using sine. Okay, now remember we need to use the inverse, so we press on the trig button this time, like we did last time, and instead of using sine, cos, tan on the top, we're going to use the inverse, so sine -1, cos -1, tan -1. In this case, we're using sine. Okay, so sine -1, and it'll actually open up your bracket for you. Okay, and then you just need to open up your fraction or activate your fraction, and then just 5 over 8. Okay, and you can just hit enter, and then there's your answer. Okay, so you don't need any solving for a question like this. You can use solve and then input theta and then solve for theta, but it just becomes a lot more complex, and it's just something you don't really need to do. Okay, so once again, if you need to round to the nearest whole number, which is essentially 0 decimal places, okay, so round, copy your number down, and then comma 0, because a whole number has got no decimal places, no digits after the decimal, okay? And then you'll get it round to the whole number, which is the same answer we got in the previous part, okay? So with a question like this, it's the same as the scientific calculator, but when we activate the solve function, which we did before, that's where the CAS calculator saves us a lot of time and provides a bit more assistance for us. Once again, a massive thank you for taking the time to watch another video brought to you by RouTube. I hope you learned a thing or two about trigonometry and some CAS calculator skills. As always, please feel free to subscribe to my YouTube channel, as once again, I'm going to continue to upload more maths content from year 7 to year 12.